Welcome to this course on switchgear and high-voltage engineering. This course explores the generation, measurement, and control of high voltages and currents in power systems, alongside protective devices and insulation technologies. High-voltage engineering is central to the safe and efficient transmission and distribution of electric power. Switchgear, which includes devices like circuit breakers and fuses, ensures protection and control in these high-energy environments. The course is structured into two main modules. Module 1, High Voltage Phenomena and Measurement. Module 2, Switchgear, Protection, and Insulation Systems. Let us begin with Module 1. Module 1, High Voltage Phenomena and Measurement. 1.1 Generation of high voltage and current. High voltage is required for testing electrical equipment, simulating service conditions, and conducting insulation studies. Generation techniques include direct current high voltages, produced using rectifiers and multipliers. Alternating high voltages, generated by testing transformers and resonant circuits. Impulse voltages, designed to simulate lightning or switching surges. High current generation is equally important, especially for testing equipment such as circuit breakers and busbars. 1.2 Measurement of high voltage and current. Accurate measurement is critical for both research and safety. Measuring techniques vary depending on whether the voltage is DC, AC, or impulse. For DC, resistive dividers and electrostatic voltmeters are common. For AC, capacitive dividers and potential transformers are widely used. For impulse voltages, special devices like peak voltmeters and digital oscilloscopes are employed. Current measurements involve shunts, current transformers, and magnetic detectors. 1.3 Corona and corona losses. When high voltage is applied across a conductor in air, ionization may occur around it, producing a phenomenon called corona. Corona leads to power losses due to ionization of air, audible noise and electromagnetic interference, possible long-term insulation degradation. In laboratories, corona is studied to understand its onset voltage, energy losses, and noise implications for high-voltage transmission lines. 1.4 Electromagnetic noise. Corona is a major source of electromagnetic noise, which can interfere with communication signals and nearby sensitive electronics. Understanding corona-induced noise allows engineers to design transmission systems with shielding, proper conductor spacing, and effective grounding. 1.5 Dielectric strength and breakdown mechanisms. The dielectric strength of a material is its ability to withstand electric stress without breaking down. Breakdowns occur differently depending on the medium. Solids, breakdown may be caused by mechanical flaws, thermal stress, or long-term aging. Liquids, impurities, bubbles, or irregularities can initiate breakdown. Gases, ionization, streamer formation, or avalanche breakdown can occur. Laboratory testing of dielectric strength is vital for material selection and equipment design. 1.6 Lightning phenomena. Lightning represents one of the most destructive natural surges. It originates in storm clouds and travels to Earth through ionized air paths. When striking power lines, lightning can produce overvoltages many times the normal system voltage. 1.7 Surges in transmission lines. Surges are sudden increases in voltage or current caused by lightning or switching operations. Surge analysis includes studying wave propagation, reflection, and attenuation in transmission lines. Engineers use this analysis to predict the behavior of overvoltages and design protective devices. 1.8 Protection of lines and apparatus against surges. Protective methods include shield wires placed above transmission lines, grounding to safely divert lightning currents, surge arresters, which limit overvoltages by conducting high current to ground, protective relaying, ensuring quick isolation of faulted sections. These strategies ensure equipment longevity and uninterrupted power supply. Module 1 Summary. In Module 1, we covered the generation and measurement of high voltage and current, corona and its effects, dielectric breakdown mechanisms in solids, liquids, and gases, lightning phenomena, surge analysis, and methods of protecting lines and apparatus. We now move on to Module 2, focusing on switchgear, protection, and insulation systems.